Hi, so let's look at this question here, which is on parametric equation taken from one of the ACJC tutorial. I think it's tutorial 4. Okay, so let's look at this proficiently. So a pirate ship shark is chasing down a ship Erica, which is loaded with treasure on a rectangular grid in units kilometers. T equals 0. Erica is at the origin 0, 0, and shark is at 10, -1. Half an hour later, Erica is at 22 and the shark is at 99. Assume that both ships follows a linear paths at constant speeds. Find the Cartesian equation of the path of each curve. Okay, I think this is pretty okay. For Cartesian curve, basically it's just an equation of line. So I'm going to just write Erica is at 0, 0. So this is A0 if you want to A0. Then half an hour later, maybe I let this be half. Okay, so A half, A0.5 is 22. So maybe I put this here, 22. Then for shark is 10, -1. So we start with 10, -1 here. 10, -1. This is shark 0. 10, -1. Then after which we have got 99 at half an hour later. There will be 0.5, 99. Okay. So if you want to find the path is here for A, that will be Cartesian equation A. What we take is we just need to find MA, gradient of Erica's, which is 2 minus 0, 8y1 minus y2, 20 minus 0, that gives 1 over 10. So hence y minus 0 equals to, okay, you can, obviously it passed through the origin, so you can don't put it there. So this is the case. So Cartesian equation for Erica, y equals to 1 over 10x. Okay, then Cartesian equation for shark will be this guy here. Here will be gradient ms, which is be y1 minus y2, then x1 minus x2, that will be 10 over 9, which is 1 over 9. Okay, then what I need to do is y minus y1. So I'm going to use 9. I use this over here, equals to m x minus x1, which is 90. Okay, so then that's it. So y goes over 9x minus 1 over 10 plus 9. So Cartesian equation for shark would be, so this is 8, sorry. So 8. That will give us 1 over 9x minus 9 over 4. Okay, 1 over 8. Sorry, I copied wrongly. Okay, next one would be B. Find the parametric equation that the model of motion of each ship using T as the parameters in hours. Okay, that's pretty interesting. So I think the first thing is to understand what is parametric equation. So here can we look at Erica's first? Okay, so look at the x component and also the y component. So here we look at x component. At the start, T0, this will be 0, and then it will end at 20. This is x component, right? So you know that the distance here is actually 20. The time taken is 0.5 hours. Okay, so you could say that Erica, the x component for x, right, is just 20 for every 1 hour. How long it traveled? We know that for 1 hour, when t equals to 1, we know the distance traveled will be 40 km, right? Okay, so we can that is the definition of speed. So speed in every 1 hour, so speed will be 20 divided by 0.5, that will be 40 km. Okay, so per hour. So in this case here, for x, right, is just for every time. So time taken now is t, right? Let's say it's t. What would it be? T would be 0 plus the speed of x, right? Multiplied by time taken, because t is the time taken, right? Or the starting point. The starting point is 0, okay? Because for every time taken, if you go by t, say t, right? The distance here, maybe I just put this as t. Doesn't matter, 1 hour. Here, let's say arbitrary t. This time taken is t. Okay, I know the distance here will be 40t. Okay, so this juncture here will just be 0 plus, because 0 here, plus 40t. Okay, so the think about that will be XA. I will just label XA because it's Erica. So XA is just X naught, which is 0 plus 40t. Similarly, for the Y component, we start with 0 here, and we know this is 2 km. It's 2 km, and it takes 0.5 hours, right? 0.5 hours. The distance is 2 km. So the speed of the Y component will be 2 over 0.5, which is 4 km per hour. Okay, so XY, YA will be 0 x naught plus s, the speed of Y component multiplied by time. The Y component is 4 km, so YA will just be 0 plus 4 times t. Okay, so that's Erica's parametric equation. Similarly for Shark, let's look at the parametric equation for the X component. So it starts off with -1, 10, then to 9. So it's 10 here, and to 9. So you know that it takes a time taken here is 0.5 hours, right? Okay, 0.5 hours. Then after which this guy, the distance traveled is 80 km. Okay, so the speed would just be 80 divided by 0.5, which is actually 160 km per hour. Now, mind you, this case is a bit slightly different because after time t, the distance here, the distance increase will be 160 km multiplied by t. Okay, so the distance here, let's say time t, right? At time t. Now, then don't forget to add the first 10 km. Okay, that's the main thing. So at x equals to t, the total distance will be this guy here. Okay, at time t, you imagine you start at 10. So after time t, you add this amount of space, right? So that will be, so for the x, the component x of Shark will be 10 plus 160t. Okay, that's that. Then similarly for the y-axis, you have got 0 here. So you start off with not 0, right? You start off with -1 to 9. So this is -1 to 9. Similarly, the distance here will be 9 minus -1, which is 10. Time taken is 0.5 hours. So the speed of y is actually just, what do you call it? 10 over 0.5, which is 20 kilometers per hour. Okay, so for y component of s, right, what you need is same thing. Initially, you need to add y naught plus syt, the time after the time taken. This is the distance covered. So this will be -1 plus 20t ys. Okay, so that's the parametric equation for both of them. So for Erica, the x component xa is 40t, comma ya 40. If you want to be better, you could just put t at more than 0, because that would be the, what do you call it, the point where time has to be bigger than 0. Then for Shark, it will just be xs equals to 160t plus 10. Then ys will just be 20t minus 1. Same thing, t is bigger than 0. Okay, so that's parametric equations for both of them done. Will Shark intercept Erica if neither ship changes course or speed? So essentially what you need to ask yourself is whether both of them ya will be equals to ys. Okay, because the thing is now, if you want to find the intersection between them, you need to, you can't use the Cartesian form because the time will not make sense. Okay, they are traveling at different time. So at time 0 is here, then time half is here. Okay, so these are the two costs they look at. So what you need is now, you need to ask yourself whether we could just let ya equals to ys, or xa. So let xa equals to xs, or either one. I think the y is easier. Let ya equals to ys, the y component. This is 4t equals to 20t minus 1. Then you get a 20t. So you get t equals to 1 over 16. This means that at t equals to 1 over 16, y coordinates will be the same. But when t equals to 16, we need to see whether xs is equal to how much. Okay, so then you 1 over 16 plus 10. Then xa equals to 40, 1 over 16. Okay, the x coordinates have to be the same as well. There will be 2.5 km. Okay, so since when ya equals to ys, then xa not equals to xs, thus they will not intercept. Okay, that's the main thing. Essentially, they won't intercept at a given time, because when both of the coordinates of y is the same, doesn't correspond to the same coordinates for x, so then they will not intersect. Okay, so that's how we do this question proficiently. If you have any questions at all, please do let us know, and I'll see you in the next question.